Okay, we are solving equations. Today we're going to see variables on both sides of the equal sign. So that is something new. All right, let's look at example 1. If we ever see like terms on the left side of the equals, we would combine them, but we don't. If we ever see like terms on the right side of the equals, we would combine them, but we don't. So the next step is, as soon as I see that I have x's on both sides of the equals, I know I have to move one of these. I have to make it disappear from one side and get over to the other side. So I always move the one that's smallest. That's just how I do it, except for one type of problem, and I'll have to show you my exception. So a negative 2x is smaller than a positive 7x, so I'm going to move this one. By moving it, I mean let's make it 0. So if I want to make a negative 2x turn into a 0, I'm going to have to add 2x. And if I add 2x to the right side of the equals, I have to add 2x to the left side of the equals. So 7x plus 2x makes 9x. I bring down the plus 19. I bring down the equal sign. Negative 2x plus 2x makes 0. And I bring down my 55. Now it looks like equations that we've solved in the past. I'm going to circle everything smushed with my x. Whatever's outside my circle, I add or subtract. So to move a positive 19, I'm going to subtract 19. The 9x drops down, the equals drops down. If I want to subtract 55 minus 19, what would I get? 36. And then I would divide both sides by 9. And if I divide both sides by 9, I get x equals 4. So the very first step was new, but the rest from here on down was all review. So if you ever see x's or m's or whatever the variable is on opposite sides of the equals, you do not combine them, you move them. All right, let's look at example 2. So, any like terms on the left side of the equals? No. Any like terms on the right side of the equals? Nope. But I see I have x's on both sides of the equal sign. I am not allowed to combine them. I'm only allowed to move them. So I'm going to move the smaller one. Is a negative 3x smaller, or is a positive 1x smaller? The negative 3x is smaller. So to move it, I need to make it 0. How would I make it disappear? By doing the opposite. To get rid of a minus 3x, I'm going to add 3x. And I need to add 3x to both sides of the equal sign. So on this side, my 16 drops down. Negative 3x plus 3x is 0. Bring down the equals. Bring down the 11. And then this is a 1x. So what is 1x plus 3x? 4x. And now it's review. I'm going to circle everything smushed with my x. Whatever is outside the circle, I'm going to add or subtract. So to get rid of a positive 11, I'm going to subtract 11 from both sides. My 4x drops down. My equals drops down. How much is 16 minus 11? 5. I undo multiplication by dividing, so I divide both sides by 4. And that's my answer. X equals 5/4. As long as it's reduced, I don't mind the improper fraction. If it makes you feel better to make it 1 1/4 or 1.25, you could definitely do that, but the improper fraction is fine by me. Smile! Okay, example 3. If you ever see parentheses in a problem, we have to get rid of those before we do anything else. So, am I distributing the 2x? No. We're just going to bring that down. What am I distributing? This positive 3. So let's distribute it. We distribute it with both things in the parentheses. So what is 3 times 4x? 12x. What is 3 times negative 3? Negative 9. And then I just bring down the equals, the 8, and the minus 3x. Now, I always want to look for like terms if I have them on the same side of the equals. So on the left side of the equals, do we have any like terms? Yes, we do. As long as they're on the same side of the equals, we can combine them. So how much is 2x plus 12x? 14x. And then I just bring down the minus 9, and I bring down the equals. Now, do I have any like terms on the right side of the equals? No. One has an x, one doesn't. So, no like terms. I just recopy it. Okay, now we're to our new step. If we have x's on opposite sides of the equals, we need to move one of those. We can't combine them, we have to move one. So I want to move the smaller one. So what's smaller, a 14x or a negative 3x? The negative 3x, so let's move it. So to make it go away, I would add, and I have to add it to both sides of the equal sign. A negative 3x plus 3x is 0. Bring down the 8, bring down the equals, bring down the negative 9, and how much is 14x plus 3x? 17x. And from here, it's all review. I only have one x, so I circle everything smushed with it. Whatever's outside the circle, I add or subtract. So to move a minus 9, I would add 9 to both sides. The 17x drops, my equals drops. 8 plus 9 makes 17. I undo multiplication by dividing, so I divide both sides by 17, and my answer is x equals 1. So we have a mixture of review and we have a mixture of new. So you just have to remember when x's are on opposite sides of the equals, you need to move one of them. Do not combine them. The only time you get to combine them is when they're on the same side of an equal sign. Now technically, it really doesn't matter which of these x's I move. I could have moved the 14x if I wanted. I just like to move the smaller one because then I'm more likely to work with positive numbers. All right, let's flip our paper. The next example, I see that I have parentheses on both sides of the equals, so that's the first thing I need to knock out. Am I distributing the negative 4? No. What am I distributing? This negative sign. Or you can think of it as a negative 1 if you want. Negative 1 times 2 is negative 2. Negative 1 times negative 3x makes a positive 3x. On the right side, I need to distribute. So 3 times 2x makes 6x. 3 times negative 1 makes negative 3. And then I just bring down my plus 5. From here, I start looking for like terms on the same side of the equals. So let's look for like terms on the left side of the equals. Do you see any? Yes, the negative 4 and negative 2, those are constants. They're numbers without variables behind them, so we can combine those. How much is negative 4 minus 2x? A negative 6. And then I just recopy the plus 3x, and I bring down my equals. On the right side of the equals, do I have any like terms? Yes, I do. These two constants are like terms, so I can combine those. So I'm just going to drop my 6x, and how much is negative 3 plus 5? A positive 2. Okay, now that I'm down to x's on opposite sides of the equals, I need to move one of these. I'm going to move the smaller one. Which one is smaller? The 3x. So I need to make it disappear, turn into a 0. How could I make a positive 3x disappear? Subtract it. And if I subtract it from the left side of the equals, I have to subtract it from the right side of the equals. 3x minus 3x is 0. It's gone. I bring down the negative 6. I bring down the equals. How much is 6x minus 3x? 3x. And then I bring down my plus 2. Now that I only have one x in the problem, I'm ready to circle everything smushed with it. Whatever's outside my circle, I add or subtract. So to get rid of a positive 2, I'm going to subtract 2 from both sides. The 3x drops. The equals drops. Negative 6 minus 2 makes negative 8. Two negatives add to be a negative. How do I undo multiplication? I divide, so I divide both sides by 3. Negative 8/3 doesn't reduce, it doesn't divide evenly, so I'm just going to leave my answer just like that. The only time I really want a mixed number or a decimal is if it's a real-world problem and I'm trying to make sense of it, or if I'm graphing, then I would probably want a mixed number or a decimal. But if it's just an algebraic problem, the improper fraction is awesome. Number 5. I actually could do this a variety of ways, but somewhere in your past, you probably saw a problem that looked something like this. So let's see here. Well, let's say you saw a problem that looks something like this. This kind of problem has a special name. When one fraction equals another fraction, it is called, anybody know? A proportion. When one fraction equals another fraction, it's called a proportion. Do you remember how we solve proportions? You cross multiply and divide. Sometimes I hear students call this the butterfly. So if I multiply this diagonal, how much is 5 times x? 5x. Bring down the equals. Then I'm going to multiply this diagonal. How much is 2 times 10? 20. And then if I wanted to solve for x, I would divide both sides by 5. And if I divided both sides by 5, I would get x equals 4. So that is a proportion, and you solve by cross multiplying. Well, that's exactly what number 5 is. I have one fraction equaling another fraction. This is a proportion. So I'm going to solve by cross multiplying. So first, I'm going to multiply my left diagonal. So I want to take 3 times x minus 4. So I need to put x minus 4 in parentheses in order to multiply 3 with all of it. When I multiply the other diagonal, I want to take 5 times 2x minus 1. So I'm going to need to put 2x minus 1 in parentheses. So to make sure that I multiply the 5 with all of that. Now this looks like some of the problems we just finished doing. I can't have parentheses in my problems, so I need to distribute to get rid of them. So let's distribute the 3. How much is 3 times x? 3x. How much is 3 times negative 4? Negative 12. Bring down the equals. Now I'm going to distribute the 5. How much is 5 times 2x? 10x. And how much is 5 times negative 1? Negative 5. Okay, now let's start looking for like terms on the same side of an equal sign. Do you see like terms on the left side of the equals? No. Do you see like terms on the right side of the equals? No. But I do notice that I have x's on opposite sides of the equals, so I need to move one. Which one's smaller, 3x or 10x? 3x. I want to move it. I want to make this turn into a 0. So how can you make a positive 3x turn into 0? Subtract it. And if you subtract it from the left side of the equals, you subtract it from the right side. All right, 3x minus 3x is 0. That's gone. Bring down your negative 12. Bring down your equals. How much is 10x minus 3x? 7x. And bring down your minus 5. Now we're in review land. I only have one x, so let's circle everything smushed with it. What's next? Add 5 to both sides. The 7x drops, the equals drops. Negative 12 plus 5 makes negative 7. I undo multiplication by dividing, so I divide both sides by 7. And how much is negative 7 divided by 7? Negative 1, and that's my answer. Not so bad. All right, we have 2 more. Now notice, these say beware off to the side. That means something, so let's look at 6. Any parentheses? No. Any like terms on the left side? No. Any like terms on the right side? No. So let's start by moving our x's. I have x's on opposite sides, so let's move one of them. Doesn't matter which one I move, they're both the same. So how would you make a 2x go away? Subtract it. So I'm going to subtract 2x from both sides. 2x minus 2x is 0. Bring down the negative 5. Bring down the equals. 2x minus 2x is 0. Bring down the negative 5. Okay, if your variables disappear, you will either be looking at a true statement or a false statement. Does negative 5 equal negative 5? Yes. When your variables disappear and you're left with a true statement, this is called an identity. And that means that every number that you think of to put in for x will actually make this equation true. So sometimes we call that all real numbers. Every number you can think of is an answer to this problem. So the solution is all real numbers, or you could give me the all real number symbol. So this is what happens when variables disappear, meaning they both became 0, and you're left with a true statement. It's called an identity, and the kind of answers you get are all real numbers. All right, let's look at this next one. Any parentheses? Nope. Any like terms on the left side? Nope. Right side? Nope. Let's move our x's since they're on the same or opposite sides of the equals. How can I make a minus 3x go away? Add it. So I add 3x to both sides. Negative 3x plus 3x is 0. Bring down the 1. Bring down the equals. Bring down the 2. Negative 3x plus 3x is 0. Uh-oh, variables, they're gone again. Do I have a true statement or a false statement? Does 1 equal 2? No. That is a false statement. When you get a false statement, that means there is no solution to this problem whatsoever. There is nothing you could put in either of these x's that would make the left side equal the right side. It's impossible. So there is no solution to this problem. And that's all. Just in the nick of time. Thank you.